presentation. So I thank my student who has helped me to make this presentation. Some more corrective outputs that will also be added in the next presentation related to the same topics if it has been there. And you can see that this is what that our recommended system will give us this output for the different type of the students or the person, and how much they are scoring. You can see over here that this is what this would be giving, that what is the overall score of that person and what type of the suggestive recommendation would be. And because of this limitations are there, which we will try to mitigate that as much as possible, and soon it will be having the much more better representations and outcome, which will give a better analysis of the analytical report pertaining to that the score, academic score, and the overall performance score of the student using this personalized recommended system. So thank you very much for bearing with me. If you have any questions, please ask. Yeah, this is the case study that this is currently my research scholar is working in this. The two of my MTech scholar and one is the PhD scholar who is exhaustively working in this area, and we have tried to level by our best outcome. Where the challenges are there that the system was we saw that it is biasing and giving towards the diverted type of that is attractions where he is giving that the good suggestions that it is good, but that was not the expected output. So we try to make that this has to be good work. If you want to see the research paper pertaining to this, some part which I have discussed is submitted, and that is not been that is accepted in the journal but not yet been published. But other part which are there that are available in my profile, you go and see those papers pertaining to that the behavior analysis. Pravesh Bansal and myself, they are there, and you will find those papers. So related to that, if some assistance for the student who are, or the children who are who do seek attentions, and they may be having the problem of uh, uh, what you call that that the parents are not been able to attend them, and they are too much aggressive and they seek attentions. Uh, or some of them are anorexic and they require certain special attentions. So the focus of that is not there, which we have not yet included. So that is another field where a special attention is required. But sometimes we have those type of the physically challenged people and the impudent people, or those which are isolated because of some sort of their geographically or demographically differences, and they need the special attention. So challenges are there that having such type of the system, whether we would be able to identify the problems and support them, so that what sort of the solutions that can be provided, that would be very much useful and interesting. So I hope that those who are in the pedagogical enhancement and required, they should also take this part as a measure for the assessment of their study. Yeah. Yeah, multiple papers are there pertaining to that. Many papers have been published. I think 5 papers we have published. Two are under publications that will be published out, but they are presented, and you will see soon those other papers. And 4 are already published, and that are in my profile. So I asked that how do you like this presentation, because this is the pedagogical part where there's analytical approach in the Bloom taxonomy, where that the student would be able to analyze that uh, in the real time scenario, unless those type of the constraints if that are not been visualized, we would not be able to make that expectation that the student would be able to perform up to that level. So I think that something like this is a very important for every academia institute and the organizations where the help from the department or the institute is required. Yeah. Any other question? Data set description, is it available in the public domain? Data set, no, it is not provided. We have kept this as a secret because the corpus of the data set is very much important, that it should not be there unless that is not been published. So once the uh, thesis of my scholar is submitted, after that we will provide this data set for the in the public domain. Yeah. So if there is no further questions, so I thank you all. Thank you bearing with me.
Thank you, sir. Thank you for this wonderful session.
Thank you.
If any question he or she can ask, while we will start to session 2.
Okay. Thank you. Thank you. I'm disconnecting. Okay.
Okay, sir. Thank you. So now we are moving towards our session 2. For session 2, we are delighted to have with us Mr. Hari Krishna Maladi, a highly accomplished professional and an innovator in the field of AI/ML. He is currently working as a solution architect at Cognita.ai, a Hyderabad-based startup focusing on practical AI and ML application. He completed his master's degree from IISc Bangalore and one of the most prestigious institution in India. He also earned an All India Rank 1 in GATE 2010 in CSC stream. With deep expertise in AI, NLP, and cloud computing and LLMs, he brings a unique perspective on how intelligent technology are reshaping industry and education. So we are excited to have with us today to share his insight on how AI transform teaching, learning, and problem solving. So on behalf of the organizing committee and all the participants, I extend a very warm welcome to you, Mr. Hari Krishna, to share your insight on how AI can transform teaching. We look forward to your talk and to learning from your rich experience and innovative work. Welcome you, sir.
Sure, thank
And
you.
over.
So, yeah, hi folks. I'm Hari. I work as a yeah, I work as a solutions architect in Cognit, Cognit.ai. So, Cognita is a company which is into AI solution space. We use accelerators built in-house to accelerate AI and creative ML solutions across the industry. Um, so, I work on both that part and also on the building of the accelerators part. I have been in conversational AI and agentic AI for the last 8 years now. I've been working in Zenoti and in Core.ai before joining Cognitive 4 months back. Um, there I was building all kinds of things from knowledge graphs to FAQ answering, document extraction, document comprehension, and text bots, voice bots, agentic AI bots, then audit pipelines, um, then support call audit, services call audit, and all the sales call audit, or all the so given a company all the call audits, and then from that all the things like like churn prediction, the using support calls. So I've worked on everything in and around the space. So for today's talk, we'll go a bit deeper into code. We will look at the code to create an AI teaching assistant from scratch. Um, I'll build up to it. We'll start off very small with how to how to give a prompt to an LLM and have it respond from. So right from there, we'll go step by step into how to build something that has context, something that responds to a conversation, something which is an agent. What is an agent? And something that has multiple agents, and then how it orchestrates across them, and how to build a UI to just put it all together. So for that, I'll share my screen. But one second. So WebEx is asking me to quit and reopen to be able to share my screen. I'll just join back in a second. Just one second. Yeah, and I'm back. Yeah, I'm back. So yeah, sorry, I had to leave because the WebEx was not letting me share my screen. Um, okay, just let's start off now. Can you see my screen? Um,
Yes, sir, it's visible.
okay, cool. So let's start from the scratch. Okay, cool. So yeah, this is, as I said, this is about building an agentic teaching assistant. So I'll go through slides at the start. I will, as and when required, we'll go to code and come back to slides. So here, yeah, these are the, so this is what we'll end up building. So we'll end up building with an AI teaching assistant, which can explain things. It can chat with students on any topic. It can generate quizzes, and it can assess answers and then help with programming. And we'll have a different agent for all these use cases, and then we'll have an orchestrator which will just orchestrate this whole thing. And why an AITA? So one is you'll get personalized attention. So AITA has time for everyone. Um, and it is scalable. It is available 24/7. It is consistent. Everyone who asks the same question will get the same response. And then it is all data driven. So there is no inherent bias in it. And then how will we evolve in the session? We'll start with giving a single prompt to an LLM. Um, we'll give we'll give a basic prompt to a GPT model, and we'll see how the output comes. And then we'll give a prompt with the entire conversion history, so that we'll show you how the n plus one message mm, in a conversion can be generated. And then we'll also add a single tool call. So something that the model does not know currently, it will invoke a tool and give you an answer. And then we'll add multiple tools, and then let the AI decide which tool to call. And then we'll create an agent. Then we'll introduce what is an agent and how an agent differs from a tool. And then we'll have a single agent and a multiple agent. And then we'll build a UI to package all of it together. And this is the tech stack I'm using for this demo, but it need not be limited to this. So I have Python in the backend. and I have fast API to serve my APIs. And I use Azure OpenAI for all LLMs. You can also use GCP Vertex if you like Gemini. If you and if you like Anthropic, go AWS Bedrock. You can use Anthropic directly. You can use OpenAI directly. You can use any of this Llama models or Grok models or anything, but the concept remains the same. And in front end, we use React with the TypeScript for a neater UI. You can also use Streamlit. You can also use Gradio. There are multiple options there. And yeah, so the first step is you. So how do you hit a LLM with a basic prompt? So here you have three steps. You create a client, and then you create a messages array, and then you call API and get response. So and then yeah, these are the things I'm using. I'm using the model is GPT 4.1, and in messages I'm using a list of messages, and then the temperature is it's a measure of creativity. So zero is less creative, one is more creative. And then max tokens, it will help in regulating latency and token consumption. So without much ado, this is how it looks like. This is this is the script which hits a single prompt on a single model. So here we create the client first. So here I'm using this Azure OpenAI library from OpenAI. And what do you want me to share this code? Yes, I'll share the code at the end of this thing. I'll share both the code and the presentation. Yep, welcome. So here we create this client. You need three things to create. Uh, let's go. Let's go to. Let's go to. I'll show you how it will look like in the console. So yeah, this is how it will look like. You have this model catalog, and this is Azure AI Foundry. This is Microsoft Azure's AI portal where you can choose which model you want to deploy and use, and then at what scale also. Here you have all these models to pick from. You have lots of models and doing all kinds of things. You have reasoning models, you have text to text, text to speech, speech to text, image to image, image to text. You have all kinds of possibilities. For the sake of this demo, I'm using GPT 4.1. So now this model, if you want to use this model, you go to use this model, and then you do a deployment. And this is how a deployment will look like. Here you can customize the limits of your deployment. You can give it a name here, and then you can say that my model version is this much. My yeah, my AWS is this. I mean, it's in that region in East US too. And then this is my limit. So this limit is shared across models. If you um, yeah, across the deployments. If you will have this 4.5 million anyway. I mean, you can either the you can either have a single deployment of 4.5 million, or you can break into multiple deployments and then have it and then give it to multiple bots. It'll help you ease out billing and then to know which bot is consuming how many tokens. And then you have your limit on number of requests per minute and then tokens per minute. That's all it is. And then content, this content filter. Content filter is it will filter out all the profanities and all the obscenities in text. So you can use the default content filter, or you can create your own content filter and use it here. You can strengthen it, loosen it, up to you. So you do this, you hit deploy. I won't hit it. I won't hit right now because I already have a deployment, which is this. So given a deployment, you have a key, and then you have a URL, which is this Azure endpoint, and the API version. That's the three things that we'll be using: the endpoint, the key, and the API version. So these three things are defined in config.py here, and we have it here. We use it here to create the client. And then once you create the client, you create a system prompt. A system prompt sets the context and the persona of the bot. So you'll say that you are a helpful assistant, a, a teaching assistant who explains things very clearly. It's as generic as it gets. It's only to set the context, the persona. If you are building an AI receptionist for a spa, you will say that you're a helpful AI receptionist for a for a well-known spa, and then you can and then you will handle bookings and cancellations. If you are building a booking assistant for an airline, you'll say that you're a helpful assistant for an airline, and your airline name is so and so, and then you will handle ticket bookings. So yeah, you will set the context here, and then you'll have the user prompt where so this user prompt goes on top of the system prompt to define this particular task. And then the way this works is you create a messages array, and you have the system prompt first and only one of them, and then you have a list of user and assistant prompts. So this is a dialogue between the user and the assistant. So the user says this, assistant says that, user says this, assistant says that, and so on. And in the nth step of the conversation, what is the next thing that the assistant will say? So now this API will expect you to have alternating user and assistant messages, and then yeah, and because we are shooting only a single prompt, we only have a single assistant here, a single user here. Now we'll take this messages array here, and we'll take the deployment name, which is this thing GPT 4.1, which is GPT 4.1, and we'll take temperature, which is 0.7, and then the max tokens of 500, and then uh, we will so this chat completions dot create, this is the API to hit this messages array against this model using this client. Now this client will authenticate and this model name will tell where to go in that, so which model to invoke, and this will tell you with what to invoke. And then here we will display the response, and then the rest is just timing information and stuff like that. So let's start off. So here the question I'm asking is, what is photosynthesis? And explain it in simple terms. Here for this demo here, hang on. So this user prompt, yeah, here. So this is what I'm asking, and then I'm sending it here, and then I'm getting the response here, which is this. This is this is the output of this API call, and it explains what is photosynthesis in simple terms. And then in metadata, you can see that 119 tokens are used. And then the prompt has taken 35 tokens, and then the compilation has taken 84 tokens. That means your input along with system and user prompt, the combined input is 35 tokens, and the entire output is 84 tokens, and on the whole you have taken 119 tokens. And then this whole activity has taken 2.32 seconds to complete. So yeah, any questions still here? Okay, let's okay, charges based on tokens, yes. So each model has its own billing, and generally it's listed in terms of 1 million tokens. So you have like $1 or something per million tokens, depending on the model. Some models are cheap, some models are expensive. You can see that in Azure billing actually. I'm not sure if it will show it here also, but you can definitely look at Azure Open pricing. Here, this thing keeps on changing every day. There is so nobody can remember this information. It changes as the yeah. Now you look at this. So GPT 5 mini global. This is 25 cents per million tokens of input and $2 per million tokens of output. In general, the output is costlier. It is 10x costlier than input. So these things excel at taking a large prompt and giving a short output, and not the other way around. So, and this is a small model. If you take a big thing, this GPT-5 Pro, it is 15 and 120. So you don't use GPT-5 Pro for everything. You will try to give the right job to the right model. You won't use a reasoning model for all the applications. And now deep research is even more costly. It is 10 and $40. O3 is again a reasoning model, which is also Omni. So it can take images and audio and a lot of other channels. Yeah. So this is you'll get this entire thing. So yes, you're right in that. Yeah, we will need to bear all the cost cut for the questions. Yes, correct. So this will save, yeah, but you would need to pay a TA anyway, right? This will save you on that. And then unlike a real TA, teaching assistant. And a real TA is not available 24/7 for everyone at the same time. So this adds value in that. And then you can index immense amount of documents or papers and all in a RAG-like setup, and then have it answer from that as well. It's not limited to just answering from its own memory. So it can know more and remember and recollect more than any human. Though its reasoning is limited, it can remember and recollect a lot. So okay, let's get going. So yeah, that's the first one. And then the second step, we'll look at the conversation history. Is the uh, same client and API as before, just that now the messages array has more things in it. You have the system prompt and you have the user assistant and user. So the second assistant, so this is, yeah, when you talk to ChatGPT or to Perplexity or anything like that, and you have a conversation with it, It is responding to your last input based on your entire conversion so far. So it uses that to do things like co-referencing and picking other entities and setting the context and all these things. If the conversion is very long, you can summarize it and do this stuff as the pre-processing step. If it is not very long, you can give the entire history to the bot, and then the bot can decide what to do next. So now here it's roughly the same sequence of steps. Here you have the same client being created. Here you have the same system message, and then yeah, you have the first question here, and then you get a response here, and then you have a follow-up question here, which is, can you give me a simple example? And then you will append this follow-up question to the messages array, which has both the question and answer. So at this point, messages array will have multiple things in it. Let's say quit. So the first question was what is machine learning, and it responded with this whole output. And second question is, can you give me a simple example? And we did not say machine learning here. We only said, can you give me a simple example? Now from the first one, it knows that this example is for this topic, and this is the message array that is built. If you can read this, this has the system prompt first, and then you have the first user query, what is machine learning. You have the assistant response, which is the entire content what has been printed here all the way till here. And then you have the user again saying, can you give me a simple example? So now if you say quit, okay. And what are some real world applications? This is the third question. And this is what AI talks about the real world applications, which is email filtering and text recognition, speech recognition, and recommendation, all this. So now, here also we did not say machine learning. It's able to associate that this question is for that conversation, and this is how the entire history looked like. Here, we said, what is machine learning? It answered that. Can you give me a simple example? It answered that. What are some real world applications? It answered that also. So you can have this multi-turn conversations with a model. And for the nth step in the conversation, you will need to send the entire array from 1 to n minus 1. Otherwise, you will have to summarize it and send it. Send the summary, and that summarization is generally lossy. So if you summarize, you will lose some information there. So you have to be judicious about summarization and only use it when you're not losing anything critical. Any questions so far? Okay, if there is nothing, we'll proceed. So now the next thing is streaming. So how do you if you give anything to ChatGPT, you will know that That's um, you ask for an array on an essay on India. So it will do this, right? It's not giving the entire response at once, but it is streaming the response. And this is a trick that is generally used to save on response time. So any model out there is only going to predict the next word in a sequence of words. So instead of waiting for it to generate all the words and send the entire response to be printed at once, you will send it out as it comes. So now this is the main metric that you will use. So the time to first token. When you have a when you have a response, how much time does it take from the last user spoken text to the first token that is generated by the model? If you don't stream, you will accumulate everything together, all 1,000 words together, and then shoot it all at once. So your time to first token is so much. If you use streaming, then it's only the time required to print the next word in your thing, and then as you speak the word, the subsequent word is generated, and so on, and hence you get this typing kind of a feel. Where do you use what? You don't use streaming everywhere. You use it mainly in conversational platforms. Like for example, you're building a voice bot. You will need to stream the output because it takes time to speak out a word, and in that time you can generate the next word. If you wait for all the words to be generated at the same time, the conversion will no longer sound natural. It will sound more like a walkie-talkie kind of a conversion. Uh, so you don't use streaming if you are say generating an essay or a summary or an email or marketing content. The time is not critical. You can take your own time to generate your own output, and that can take any amount of time. So yeah, I mean, okay. So first of all, okay, sure. So yeah, if you don't want tokens being charged, then you need to host your own model. And hosting your own model is an expensive affair. So you need, even for the very basic 8 billion model, which is not good for anything more than finding out sentiment and stuff like that, you will need serious amount of computation to even to infer from that. If you want to host something like the GPT OSS 120, you will need a multi GPU instance to be able to answer quickly. Open source, yes, they are available. Yes. So this is one of the models, GPT OSS 120B. This thing is open source, but it's a 120 billion parameter model. So it's a mixture of experts. So you will need a GPU instance to be able to be able to use this. That means you have to pay for the instance if you don't pay for the model, and that will be like a standing cost whether or not the model is used. So you go for your own deployment if you have the infrastructure and if you know that it will be used to that level. Otherwise, you are actually better off paying per token and um, go with an on-demand kind of a setup where you can choose which model you want and you just pay for 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 what you use and with no standard cost. So here, if you can download this thing and use it as it is. Now, just follow this thing. You'll actually download the model and use it. You can deploy it on your own also. And here you can deploy it on your own also. Like 20B, you might be able to deploy it on a laptop. Okay, let's see that. Let's look at, yep. You need an 80 GB of GPU memory. So you need something like a H100 GPU. And for fine tuning, you need an extra 65 GB of memory. Yeah. So this is what you need. And it'll cost a lot because we have done this in our place. So yeah, this 20B is something you can do it on a desktop actually. If you have a very serious GPU desktop, like a gaming desktop, you can install the 20B on it. But 20B is not useful for anything other than very simple summarization and sentiment analysis kind of a task. You cannot give it any reasoning stuff. You cannot give it any complex flows. But 120B you can, but you need like 80 GB of VRAM. Yeah, so it's always a balance between scale, pricing, and usage, whether you want to host it on your own or whether you want to take an on-demand instance. So okay, let's get back to this. Um, Now the same thing here is first for streaming we have the same configuration, the same client being created, but this is without streaming example. Here I put the stream equal to false. This is the default state. Then we give it a prompt and then we look at the time that it takes to respond. And for streaming, you have the same deployment, same message, same everything. All these three are same. You have stream equal to true. And then as the stream comes in, so it returns a stream here, not a response, but a stream. And in this stream, chunks keep coming as the model keeps answering. For every chunk that comes, you will print the chunks content. And then as long as there are chunks in the stream, and once the stream ends, we come out of this loop. And then we print the time, the total time taken. And then this is the first chunk time, which is the time to first token. And then we have the complete time also. And the same client is used here, and we have the prompt as explain photosynthesis one in 150 words, and then we call the non-streaming first, and we call the streaming next, and then we compare the results. So in non-streaming, you can see that it has taken uh, so 3 seconds to complete the entire response, and then once you hit enter, this is the streaming version. Um, oh, something failed here. How are banks doing this today? Do they follow internal process? And if they want agent assistance for department policy, are they building their own? Yes, they are building their own infrastructure. And this is exactly where companies like my company come into play. We do on-premise installations of these things also. We use this GPT OSS 120B and all. We deploy it on a bank's premise. And then we also keep it completely local for them. And this is also the reason why banks don't have very chatty assistants. They follow a simple flow based approach because they don't want to use LLMs in most cases. And this is the entire reason why you have where you don't have voice bots just filling the space. You don't have voice bots for everything in the world. Though you see demos everywhere, you don't see products everywhere. And this is the reason. So yeah, just a second. Let me see what is here. Let me debug this or what is going on. I'm not getting in any stream here. Okay, fine. I'll check this thing. We'll get back. We'll pack this. I'll get back to this. So we'll look at tool calls next. LMS portal, no. It will help you build a bot which can use your portal. So here in tool calls, you will try to compensate for the fact that LLMs don't know everything. They don't know what is the date today. They don't know what is the weather today. They don't know your location. If you're booking an appointment, they don't know what flights you have. They don't know anything on what services you have. It's only a language model. So you want to give your own context to it and let it answer, which is where you have tools. And for tools, you create one tool or multiple tools. You create tool descriptions, you create parameter descriptions, and you let the model infer which tool to call where. So this is an example. This is a single tool. So here you have generate quiz is a tool. First, we'll run this thing. So here you see this. Then I'll explain to you what is going on here. So yeah, this is the tool that we use. So and the tool name is called generate quiz. And here we generate the quiz on a topic based with a given number of questions. And then the number of questions default is 5. And then here we say that the topic is required and the number of questions is optional. If it is not given, it is taken as 5. If it is given, you'll take whatever is given. And then the number data type is an integer. The topic data type is a string. And then you also describe what to be taken as a topic, and then what to be taken as a number. Your response can contain multiple numbers. It will only take one of the most relevant one as the number here. And then you have these tools. You have the same client which is created as always. You have the messages array. And then to the API call, you give the deployment name, the messages array, and the tools. And then you say that the tool choice is auto. So in tool choice, you have multiple choices in tool choice. Auto will let the model decide which tool to pick. You can force a tool also, or you can say that pick only one tool or pick multiple tools. You can say that if the current tool is so and so, the next tool has to be something else. You use that if you want to enforce a flow in your tool calling. As we have only a single tool here, we leave it to auto. And then we let the AI choose where to pick it. And if the tool is picked, then we say that AI has decided to use a tool, and then we and then we go and call the tool. So the tool calling will not automatically run anything. It will just pick a tool from this thing and give the tool name. It's on the code to take the tool name and call the right function in code. So here, if the tool name is generate quiz, then you call the function called generate quiz with this topic and that number, and then you will get the function executed. Now that function can call your database or your LMS in this case, Satish. And then that LMS can give you your quiz. But then the AI agent will only decide when to call the LMS. It won't build the LMS for you. So this is how it will look like. And then here, yeah. And okay, and here, okay. Yeah, correct. So that is the use case for tool calling also, and for agentic also. If you want to if you want to create an assistant bot in your LMS, and that is your AI teaching assistant, right? When you want to create an assistant bot, so it has access to all your. Yes, this code will help. This code will help you build the bot for the LMS, not the LMS itself. So here, if you see this thing, you have available tools is this one tool, and then the student asks, can you create a quiz with 3 questions? It has entered to AI, and AI decided to use a tool. Then this tool, it overrode the default 5 with 3. So 3 questions. The topic is Python basics. It called another AI with this with Python basics and 3 questions to give you the 3 questions on Python. Now, if you say that if you say that 15 questions, sorry, 15 questions. Yeah, this is what you get. And you say, let's say quantum physics. Yeah, this is what it does. It picks the word quantum physics from your utterance as the topic, the number of questions as this thing, based on what you described in the tool definition of how to pick a topic, how to pick the number of questions, and when to call the tool. If you just simply ask, what is quantum physics? It will decide to not call the tool. It might decide. I don't know. We'll see. So here it has not called the tool because we not asked you to create any quiz. We only asked what is quantum physics. So it decides to call the tool based on what description is given here. Or you can also force it to call the tool by saying that call the generate quiz tool with. You can force it to generate to call a tool like this. Yes, here it has called the tool. Though we did not say that you create a quiz, it called the tool because we forced it to call the tool by adding it in the prompt. So let's just bring it back to this state. Any questions still here, or are we all good? Are we all good? So Satish, anything you want to add here? I do have, at the end of everything, I have a US setup issue. So I'm building slowly towards that. So these are tool calls. Here you have now you have multiple tools, which is the next thing. Uh, and yeah, this is how a tool call works. You get the question from the user, it decides if tools are required. If a tool is required, you call the tool, you execute the code which is there in the function of the tool. You send the response back to AI and it creates a final response. If it decides to not call the tool, it'll just go straight to creating the final response and then speak the response out. And here for multiple tools, I have these three tools created: generate quiz, explain concept, and assess answer. Now the problem here is, what if you have very closely spaced tools? So say you have tools called reserve booking, confirm booking, and book appointment. In English, they are very closely worded. So there's a very high likelihood that the reserve will go to confirm will go to book can go to reserve, or any other combination. And even the same in the same utterance can go to to reserve once and to confirm another time. In such cases, you need to keep adding more descriptive definitions. And as I just showed you, you have to say that invoke this particular tool at this point. You need to actually write it down in the prompt. Otherwise, it'll get very hairy, and this is what is all the hallucination is all about. If you want to minimize hallucination, you need and make things more deterministic, then you have to describe them properly, like both in the tool definitions as well as in the prompt. Tool is not a function. Tool is where you help the AI to decide to call a function. So the function is in your code, yes, but the function is not executed all the time, right? The function is executed only in some circumstances, by taking the parameters from your speech, from your text. And when to call and with what to call is AI's decision. So tool is how you define, how you help the AI to take the right decision. That clears up? Okay, cool. So here we'll just look at this. We have three tools. One is generate quiz, where the same thing as before. You have the topic, your number of questions. You have explain concept on another topic, and you have assess answer, which is with an answer and a question. You create three tools. You have these test cases, which is the first one is create a quiz in Python. What is machine learning? And grade this answer. And then you hit all of them against it, and then decide which tool picks what. Yeah. So here, so generate a quiz with three questions. It went to generate quiz. In generate quiz, this is what is taken, and this is the output out. And explain what is machine learning. Here we go to this part. So it goes to explain concept, and the topic is machine learning, and then it will explain that machine learning is so and so. Here, grade this answer. Python is a programming language, and here the question is what is Python. The answer is Python is the programming language. It will it chose the tool called assess answer, and then assessment, it gave an assessment for this. So this whole thing is working based on the descriptions here and the property descriptions here. So this is what I mean by deciding to use the function in code, because these three things are three different functions in code, these three functions. So the AI is deciding which function to use at what point in time, which is the entire power of tool calling. You can have like 100 tools and one tool enforcing the use of another tool. You can create chains of tools. You can say that to book my appointment, I need to know the date, the time, the service, and the provider. To know my time, I need to know the date, the service, and the provider. To know the provider, I need to know the service. To know the service, I need to know nothing at all. So if you want to chain all these tools together, you can actually use tool choice to enforce that once you come to service, you can only choose the tool called provider. And that is if it is applicable. From provider, you can only go to date. From date, you can only go to time. From time, you can only go to confirm. So now this chaining is possible. And then you can say that you can have hundreds of tools. You can enforce chains. You can enforce tool calling tool. You have and one input can call multiple tools. The output of one tool can be the input of another tool. You can chain them in any number of ways, which is the entire power of tool calling. Are we good till here? Okay, so let's continue this. Okay. Which course would you actually no course? I would advise you to take a project and do it hands-on. So I mean so whatever you said, right? So creating a assistant for your LMS, that is a brilliant example. You can take that example and take it to completion. And you don't need any more tech than whatever is here. You will only keep building on them on this thing. You only add more tools, you will yeah, sure. So you will need to build on these functions. So here I'm just hard coding an output. Here you will call your LMS or API and then give that API response here. So that's how it will work. So you need to just go deeper into these functions and then add more functions. You give it to a model and keep tweaking the prompt and the descriptions and slowly build it. So yeah, now the next thing will go to what are agents. So this word called agent or agentic AI is being thrown about everywhere. So this is a very abused term like the word AI itself. So you have agents which are, if you take for example this thing, here I have this, here you can, so each tab is called an agent here. And for a very good reason. So an agent is something that can act independently. It has one context and one context alone. It has one responsibility to do. And then how does it differ from a prompt as an LLM? An agent is more autonomous, so it can write your code, debug your code, run your code, write it again, debug again, run again in an infinite loop. And in fact, this whole repo is generated using AI itself. So yeah, it can act independently. It can do multiple steps. you can have an agent consume its previous step as input and keep going forth. You can let it you can actually give it a screenshot of your error and have it debug your entire code. You can, and it'll just keep running debugging, write one test, run the test, debug from the test, and then so on in a loop, all the way till it actually accomplishes the goal. A prompt with an LLM is stateless. It will it's just a model and a piece of text. You give it an input, you get an output. And generally, it's not a black or white scenario where you have prompt or an agent. It's mostly a gray scenario where you call something an agent if it has single purpose and can invoke tools and APIs and other things. And prompt with LLM is a simple like ChatGPT. You just give it a prompt and you're done. And here it is one shot and stateless. That means it is your there's no conversion history. So here there is a history and state management. Say you build a bot, you will not really put things in memory in the messages array. You will actually have a state variable on disk or in a NoSQL DB like Mongo or DynamoDB, where you will actually store the conversation so far, and the user can come back tomorrow, and then you'll continue the same conversation. You'll not erase everything and start from scratch. So this state management and persistence is there in case of agent. In case of a single prompt, there's nothing. In case of so for interactivity, it can actually call APIs, make changes. It can book appointments. It can fetch appointments. It can answer questions, create quizzes, create things, change database entries, do multiple such things. And a simple prompt, it's only reactive. It's only text. You give it an input, you get an output back. And for example, an agent example is an AI assistant booking a flight and then sending the email about the booking. It's a multi-step process. And then you have and the example of a prompt is just to summarize something or to draft an email or to draft your resume. So an agent is like a function call, but a bit more than a function call. You need a well-defined system prompt. You need bunch of tools. You need persistence and generally an agent will do a single activity. So an AI teaching assistant is a combination of multiple agents. So because that role has multiple responsibilities to it. So he will help you in teaching, he'll help you in answering questions, he will help you in grading questions, generating exam papers, all these things. And then these things, instead of having the AI just um, so called tools from a collection of tools for all these things, you can actually assign each responsibility to an agent and then just call the right agent for the right task. So are you good till here? Okay. Okay, cool. So we'll do the same example. That is up to you. So you can you can decide whether to keep private data or not. It's on the way that you code these agents. So it's totally up to you, and you don't need agents for it. Yes, absolutely. Yes, that will work. So we will need to limit students to course materials only. That is something you get through RAG, through retrieval augmented generation, where you index all the course materials into a RAG, and then have your agents access that RAG alone, so that it won't go out of bounds. And then you can say that for the banned or unused word or unsafe words, this is what I was talking about here in case of the just hang on. Yeah, so here I have this thing, right? this content filter. You can create a new content filter with all the banned and unsafe words, and then have it block responses based on that. So this is called multiple things in multiple places. It's called content filter in Azure terminology. You can also have guardrails, which is again it's like a second layer of defense on what not to say. So yeah, let's get back to this. You have single agent. So we'll do the same multiple tools example using agents. That's the objective. So here you have a single agent, you have a chat agent, and then this chat will just handle multiple iterative conversions. So it has its own system prompt, it has its own state, its own independent operation, and a purpose, which is to chat. So here you create an agent, you create the client here, you set a system prompt, you call the class as chat agent. So in Azure, there is no agent support natively. In case of AWS Bedrock, there is something called Bedrock agents where you can do all these things in UI. So here you have self-brought messages where you like before you can set messages here. Then you can say that my agent is ready. This is the init part. And when the chat function in this thing is called, you will append this parameter to the messages array, and then you will hit it against the API, and then it will respond. AWS or Azure, which is best to use, both have their own pluses and minuses. They're both roughly comparable. I have used both extensively. I prefer AWS Bedrock to Azure OpenAI. But I am giving this demo on Azure OpenAI because my current company uses Azure. But otherwise, I prefer AWS because AWS has a lot more functionality than Azure. You have, so Bedrock has uh, so prompt management, it has its own RAG, it has its own flow management, agent management. You have all the Anthropic models, and you have the Boto3 library, which will let you use any AWS service from any service can call any other service with no additional auth. But just because my current company is using Azure, I am giving it on Azure. On Azure, you have access to OpenAI models, which are not there in AWS, and you don't have support for all these flows and agents natively. So you have to write it on your own, which is what I'm doing here. So yeah, now this is what I call by persistence. I keep this self-dot messages variable in init. Actually, actually both are free. Radhakrishnan, both are free. So you have a free tier in both AWS and Azure. Uh, as long as you stay within the free tier, there is no charge. And if you are a startup or a company, they'll actually give you free credits. Like we currently have 200K worth of credits in Azure, which is why we are on Azure. We are not exhausted that. So okay, now getting back this the self dot messages is the persistence part. You keep appending to it. If you can also write a function which will actually save it to disk or save it to a DB, then you will have it persist for longer across logins. You can have someone talk today and then come back tomorrow and then continue the conversation. If that is not your objective, just keep it in memory and erase it once the chat is over. It's a use case based thing. Yeah. So if you look at this, here my chat agent is ready, which is just the initialization is ready here. Only the system prompt has been set here. Set here. Then I ask what is Python. It answers about what is Python. Then it gives an example and everything. Then can you give me an example? So now this goes on top of this message array. And then here we say that it gives an example. So and then the student asks, what can I build with it? Then it answers that also with project ideas and all this. And then the agent currently in this state has 7 messages. So because the user has asked 3 times, it has responded 3 times, and there is a system prompt. And this is the system prompt. And then you create a reusable class which you can use in a multi-agent setup. It has its own state. The message array is now private to that class. And then you have a specific behavior which is set up a system prompt which is also private to the class. And then you have a clean interface which is dot chat. So you create multiple of this agent classes. You create an object for each of them. All of them have dot chat, and then you have you have one orchestrator agent which will just decide which chat agent to call, and then you're done. So any questions still here, or is this easy clear till here? Okay, so so we have these 3 agents. So the chat agent is the class called chat agent. Here we have this system prompt, this message list, and chat, which is the same thing as what we showed before. We'll go to this chat agent is this. So the question asked here is what is Python? And this is the response. It's a high level language and so on. Now let's go to the next agent, which is explanation agent. So the explanation agent uses a different system prompt, which is about explain concepts clearly with these 4 conditions. And here you have the message array, which has the system prompt and whatever is given here. And then you hit it against the API, and then you get. So explain of machine learning. This machine learning goes in as a topic, and this becomes the system prompt. And then we append this explain before explain the topic. So this is the output of that. About explanation agent, you'll get explanation about one topic. The next is a quiz agent. And this quiz agent has this init where you have the system prompt saying that you're a quiz generation specialist. You will generate quizzes with 4 options, and indicate the correct answer, and then you have the number of questions and you have the topic. And then you will give the topic and number of questions as parameters here. So here, for example, here Python basics and 3 both go here. So it generates a quiz of 3 questions on Python. All of them MCQs, all of them with the key. This is the output of the quiz generation agent. And if you look at it, all 3 of them are self-contained. Each class has its own private variables, which are the system prompt and the client, and also the messages and everything. And each has its own interface to talk to the world. It's just this. And then we'll go to the orchestrator. It's the same 3 agents as before. And then we have a 4th agent called an orchestrator. This orchestrator will decide which agent to call. So an orchestrator is a class again. We'll run it once. So what is Python goes to the chat agent, where it responds with what is Python. And then create a quiz on machine learning goes to the quiz agent, where it will create a quiz on machine learning. Explain photosynthesis goes to the explanation agent, where it'll give you the explanation on photosynthesis. And then how are you today goes to a chat agent, which will again do small talk. And this is where it is. So here in this root request, we say that so once you get you say that your routing prompt is this. So given this user request, which agent should handle it? You have the user request which comes in as input here. You say that I have these 3 agents, chat, quiz, and explanation. You respond with only the agent name. You can actually replace this prompt with a function call, with a tool calling example, where you define the same things as tool definitions, and you can call the right agent with the right tool. You can have tool calling here, calling agents there. And then you give it to the model, you get a response, and then from this response you pick the agent name, and then given the agent name, if the agent name is quiz, you go to the quiz agent. If the explanation goes to explanation agent, otherwise you go to the chat agent, which is for everything else. And this is an example. So the first one is what is Python. So if you just say explain, or you just say explain what is Python, this should go to explanation agent. Correct. See this? So yeah, there's four things they go to all the agents, and then agents will respond, and that completes this demo. Are we all good till here? Okay, cool. So yeah, this is and this is the final UI for the whole show. So in the ninth one, backend have the same stuff. I have the 3 agents, and I have the orchestrator and the 3 agents, and I have an API.py where I use fast API, this part, to serve to create a REST API to access this whole thing. and everything that is spoken of will go to the orchestrator first, and then from there it gets routed to various places. You created multiple routes. So you have a health check, you have a chat, then and this chat will go to the orchestrator. And yeah, this is what it is. It goes to orchestrator. It'll tell you the agent to use. If the agent is quiz, you route the request to the quiz agent. If it is explanation, you go to explanation agent. If it is something else, so you go to the chat agent. The same logic we had in orchestrator here, we put it in this place called API here. And then you expose it all as routes, and then here you see that API agents will get to the list of all agents, and that's all. This is the backend part. The front end part is yeah, this is a very simple front end built on React. So we'll look at this. Sorry. Yeah, this. So this is how the front end would look like. Here, now if you look at this, I have these 3 agents available. Okay, thank you. Then you can, these are all the things you can ask it. You have these 3 agents. You can talk to it here. And here, this chat agent has been invoked here. Yeah, just a second. Let me just put this here. Sorry. Okay, now what can you do? So yeah, it goes to chat agent again, and because it knows that it is a TA and it is, and it was its responsibilities, it'll tell you what it can do. Tell me about Python language. So it goes to the chat agent again, where it talks about Python. Then you can say that explain in a bit more detail. It goes to the explanation agent, where it will decide. It'll give a bit more depth to it. Create a quiz on Python. This is, it creates a quiz on Python like this. So this goes to the quiz agent. And then you say something else like, okay, thanks. It goes to chat agent again. So in this case, I'm deciding on every input to send to which agent. You might not really want to do that. You might want to stick to a flow. If you have a flow, if you are a booking management bot, for example, and you have a flow for each of the operations you do, if you start a booking flow, you'll stay in the booking flow till you actually complete the booking. So in such a case, you would want to set the flow somewhere in a DB or somewhere like that and read it on every single utterance. And then if the flow is not set, go to orchestrator. If the flow is set, you go to the flow directly. You will skip the orchestrator. So yeah, that's a call you need to take. So depending on the use case. And you can clear the chat. So yeah, this is the demo I wanted to show you. I'll give you the code for all this. And the way you run this is all there in the, it's all there in the README. I don't have this on GitHub yet. I will put it on GitHub and give you. Sure. I will share the GitHub repo. So yeah, I mean, this completes my talk. Um, I think we have another 20 minutes, so let's open it up to discussion. Any questions, anything, anywhere you want advice or help or anything like that. Okay, so almost 1 minute now. What should I recommend the students at 3 levels, freshers, 10 and 5 and 10 years experience? Should they focus on? Okay. So agentic AI is becoming very democratized now. Everybody is getting into it. So that's a skill that everyone needs to have. If you don't embrace AI, you will be obsolete very soon. But AI will not take your jobs, that is for sure, because no, as we are seeing in the industry, you cannot really rely on vibe coding for everything. I- Human creativity cannot be replaced with AI, so that is becoming more and more evident. But AI is enabling developers to be 2x and 3x more productive. So a single person can output um, a lot of production ready code in very short time. That is clearly there. So machine learning is not obsolete. It can never be obsolete. All these things like churn prediction or demand forecasting or market mix modeling, all these classical machine learning use cases, they cannot be done with Gen AI. They still require the old statistical modeling and data science and ML. That cannot be replaced. So yeah, and Kubernetes and AWS Azure, yeah, these things they come and go. So there is, I mean, unless you want to career in DevOps, there's no need to actually master a cloud. If you want to be in DevOps, then yes. Otherwise, it's okay if you have you have working knowledge of these things and you can get by. I mean, when you're faced with a hard thing to solve, you will actually do some debugging and searching around, but otherwise you'll get by. And also the layoffs are not really a big concern because there are also companies hiring. There are companies hiring across the board. So, and these things are just part of life. So you will, uh, I would think of layoffs as more like a redistribution of workforce. So, I mean, everyone I know who was laid off has got a job within a month, and in most cases with a hike. So, yeah, I mean, as long as you are rightly skilled, it's not much of a concern. And there are startups coming all over the place. So there are many laid off folks are actually starting their own companies and becoming entrepreneurs, and then they are getting funding and hiring their own folks. So this is actually a good thing. This is boosting the ecosystem. And yeah, what? So yeah, I think I've answered all the questions here. So do you want me to answer anything else in specific, Satish? Or any other questions? And okay, so orchestration can take multiple forms. I'll actually give you another thing. So hang on. Yeah, this is a talk we gave at AWS Summit this May. This is a talk we gave at AWS Summit this May. This is from my previous company called Zenoti. And here we built an AI receptionist which is a voice bot which does all your booking management on a phone line. And Zenoti, in case you folks don't know, is a SaaS platform for wellness, for spa salons, for med spas and gyms and so on. They do everything from booking, appointment management to payroll, inventory, and payments, and basically the whole show. And AI receptionist is an AI receptionist. It's an AI front desk. So we have built a platform for Zenoti, which where a customer can just set a few things and and they will have a AI receptionist taking phone calls for them, or also making outbound calls and confirming appointments. So this is how. So we built this on top of an existing platform called HyperConnect. HyperConnect is something that looks like this. This is a one-place contact center solution for all communication. So phone, SMS, bot communications, or anything like that. Each communication comes up as a card in HyperConnect. Each booking cancellation and reschedule comes as a card in HyperConnect. Um, f- Phone actually comes if like someone is calling you, it will actually ring in HyperConnect. You can transfer calls in HyperConnect. You can go from HyperConnect to physical phone to HyperConnect. The entire thing is handled in HyperConnect. So by by AI receptionist, we mean that it's an just another receptionist on HyperConnect, but this receptionist is not human. This is an AI receptionist. So here we use this is completely AWS stack. We use AWS Amazon Lex for our text bot. So Lex is the old school thing before Gen AI, where you could actually write rules for entity and intent identification, set flows. You can make a chatbot completely with purely pattern matching and NLP with no Gen AI as such. It's purely conversational AI. We use AWS Transcribe to analyze calls which already happened, AWS Bedrock to build the AI receptionist. And our use case was to give a guest summary, call analysis, suggested responses, and also to answer on social reviews. So here our AI receptionist, we had to build it because we had so many incoming calls being missed, and they are missed because they come in off hours or they come in peak hours when there's when the front desk is overloaded. And we have done an analysis and we saw that most of them are appointment management. Like very few of them are for inquiry. Most want to book, cancel, or reschedule. So these three flows you can actually map them out by listening to few thousand calls. We're able to see what steps are generally taken in what kind of an industry, and then we created this thing. So this is our high level um, component diagram for a receptionist. We have the telephony provider, in this case it was Twilio. We have the three agents, and then we have the RAG sub layer, which has all the things around the price of services, the service descriptions, and so on. And we have the tool calls for all these things. We have the language models. We have and a bunch of stores behind. And then here we have a multi-agent system where you have a routing agent, which is the orchestrator. You have an agent for each of the flows that we have taken. And then now these flows, they all either go to Claude Sonnet or Nova Pro or currently other models. And then now this orchestrator, it behaves a bit differently from the orchestrator we have in this code, because in this code, each input goes to the orchestrator and that is that. We don't do anything else on that. So if you look at this, so we just ask this orchestrator to just pick a flow, and this agent, so here we just we here we just say that you have these three agents. You pick an agent and then we'll and then now this request will go to that agent. But if you're booking an appointment, your response is sometimes a single yes or no, or it is just a service name, or it is just a confirmation, or just a time, or just a day, or tomorrow, or day after tomorrow, something like that. Once, so for these utterances, I cannot really pick an agent. So I set the agent at the first. So when you say that I want to book a haircut for tomorrow, or I want to just book a haircut, or I want to just book, I I will set the context to booking agent so that all the subsequent conversation will go to booking agent alone. Now this booking agent will also have a tool which will reset this flag so that in the as I'm booking, I suddenly recollect to cancel. I can kill the agent till here. I can start cancellation and then do cancellation from this point. So in booking agent, I have a tool which will reset this flag. And that resetting will happen only if it is confident that you want to change the flow. So say you're canceling and then the bot will you want the bot to convert the cancellation into a reschedule. So there you will actually prompt, do you want to reschedule here? If you say yes, that yes will reset this flag, and the flow will now divert into reschedule with all the things already filled. So yeah, here the orchestrator it does something more complex than just this part. It sets a state, it decides when to unset the state, and yeah, and it's also a time-taking thing to call the orchestrator in every iteration because it also takes a second or two. And when you talk to something which has agents and the agents have their own RAG and they have their own tools, then each utterance that you speak will go through 3 or 4 LLM calls. One to select where to go, one to select which tool to call, one to call the tool, one to paraphrase the tool. And if you also add an orchestrator over this, you will actually get 3 to 4 seconds between you stopping your speech and the bot talking, the time to first token. Now you don't want that to happen, so you try to minimize the number of calls. So you will skip the orchestrator in all but the first step. You will try to cache everything else. You will put more functionality into tools. In some cases, you will not even call tools. You will put the tool output directly in the prompt. Like say you're calling a front desk and the front desk knows that this phone number is yours. So they by extension know what did you book last, whom did you book with last, when is your birthday, do you have any gift card points remaining, and all these things. So instead of calling tools for all this, I will pre-cache this information. I'll populate the prompt dynamically on the fly when you call with this information so that now the bot already knows this stuff. So once you ask what is my gift card balance, it won't really need to call a tool. It knows already. So you'll try to optimize on that. You'll minimize the number of tool calls. So along with tool calls, if for each tool you'll also call LLM one more time. So if you minimize that, you also minimize. You also cut out another call. So you do all this to bring down response time to under a second, and then you don't use the same model in all the places. Your orchestrator will be powerful. Your paraphrasing will be faster. You will use say Claude Haiku in one case, Claude Sonnet in one case. You will try to boost your orchestration, but you will try to make your other prompts smaller. So yeah, all this engineering you would require if you have a time sensitive application. So does that answer your question, Satish? That okay, sure. So yeah, that is something bit more on orchestration. In this example, I just gave a very basic overview of orchestration. Yeah, but otherwise, that's a bit deeper into it. Any other questions, anyone? Oh, thank you. Thank you. Thank you. If no one has anything, we can actually close it off. I think we are 8 minutes ahead of schedule. So we can, yeah, we can actually take more questions if anyone has any other questions. Okay, yeah, if there's nothing, we'll wrap it up here.
Okay, thank you, sir. Thank you for this wonderful session. If any have any questions, he or she can ask.
Welcome, Ashok.
Thank you, sir. Then we will conclude the today's session.
Sure, we'll conclude. Yeah, thank
Thank
you.
you, participants, for joining. Thank you all. Have a great evening.
Thank you.